So I'm Marco, this is William, you already met him. I work also as an engineer in HAProxy, mostly in Golang, so Fusion, Data Plane API. And today we'll be talking about ACME and how HAProxy fits into it. So yeah, let's start. To set the stage, let's first talk about ACME and why is it important today. Let's talk about the problem. What problem is ACME actually solving? Let's all remember the past times. I'm sure some of you here dealt with certificate renewals in the past, and you had to set reminders, spreadsheets, a bunch of notes. And the core problem with that is that it was a completely manual process. And in that manual process, you know that it's complex, it's error prone, and it chews up your valuable time. The impact of the manual process is that the panics became a common symptom. You often had urgent last-minute scrambles fueled by the dread of expired certificates. And the ultimate business impact was the constant risk to availability. A simple mistake in your manual process or a delay could lead to connection not secure warning, which would actually erode your users' trust. And now that we talked about the problem, let's talk about the solution, the automated certificate management environment. So Let's Encrypt launched in 2016 as a free automated certificate authority by the ISRG and introduced ACME, which is basically a protocol that was standardized in RFC 8555 in 2019. ACME is a protocol or environment that supports the whole that automates the entire certificate lifecycle, from issuing the certificates to validation, to renewals, and to revoking them if they are compromised. Now that we know what ACME is and what problems it solves, let's talk why it's critical today. So the main driver for ACME and automation is the undeniable trend of rapidly shrinking certificate lifespans. Firstly, Let's Encrypt in 2016 when it launched basically set the 90-day certificates as a common practice. This moved the goalposts for constant certificate renewals that needed to happen. Second, it's not a static situation. This situation is moving. We've seen in the latest CAB forum ballot that happened in April that they voted for having a maximum public TLS certificate validity from 398 days to only 47 days. The goal of this is to have better security through faster rotation of certificates. And when we take all of this into account, we see that manually renewing certificates every 47 days or every 90 days, it becomes not practical and not really scalable. So the consequence of this pressure is basically that automation of certificates is no more optional, it's basically becoming required. And ACME is here to provide the environment or the protocol for that. Now let's move to, So let's move to see how actually HAProxy helps us tackle this and leverage ACME effectively. The current state of affairs, how most of you that are using Let's Encrypt or ACME are now working, is using standalone third-party clients and some external scripting. So basically, I noted here some popular options. There's CertBot, it's Python-based, it's an official ACME implementation. There's Lego, which is quite minimal. It has excellent support for solving DNS challenges, as it supports a vast number of DNS providers. And then there's the well-known ACME SH, which is shell-based. And the typical workflow with all of these clients is that you run those clients via cron or some other scheduler or manually to fetch your certificates. Then you have some external scripting for answering HTTP challenges or for preparing the certs, inserting them into HAProxy, loading them via the runtime, or just reloading HAProxy and loading the new certificate effectively. It's a functional system, but as we'll see, it has its drawbacks, and that's what we are working currently to address in the HAProxy 3.2. Here's a short example how you can actually run ACME and HAProxy using Lego. So here you use Lego to solve a DNS challenge, in this case Route 53. You fetch the certificates you need, and you use these two commands to insert the certificates into the stat socket of an HAProxy. LEGO supports, I think now, 153 DNS providers, so probably most of your DNS providers are supported with this. And now I'll hand it off to William to talk more about the ACME SH implementation, as he's the contributor there, and we officially support that integration.
Thank you, Marco. So we needed something light and portable for appliances, something with a few kilobytes, no dependencies. So we found about ACME.sh, which is pretty popular. So it is lightweight, minimal dependencies. So it's only a big POSIX script using the OpenSSL binary. It's a full ACME implementation, meaning you can do the HTTP challenge, the LPN challenge, and the DNS one. And it supports HAProxy natively. However, it was kind of limited because you still had to reload HAProxy. So we wanted to contribute to this, and we added the dynamic update over the stat socket. So this is a small example with ACME.sh. So basically, you need two important elements, which are the stat sockets, so ACME can use it, and the HTTP request rule, which will answer the HTTP challenge. It's two commands to use it. There is a issue command, which will ask for the challenge, which will generate the certificates. And then you have the deploy command, which will call the deploy script, put the certificate at the right place, push the certificate within HAProxy, and then you just have to put acme.sh in a cron tab or something else, and it will call these two commands every few weeks. So acme.sh didn't need to reload HAProxy anymore. It didn't need to be root, meaning you can just use the HAProxy user with an access to the stat socket and a directory with the HAProxy user too. It's quite simple to use, but it's not well integrated in distributions, meaning you don't find packages easily. There is a Docker image, but it's not for everyone. So it's quite difficult to maintain. And there isn't a stable branch. It's not a long-term support product. So it was limited also for the HAProxy configuration. You will need to use a directory and only a directory. You couldn't use, for example, a CRT keyword or a SSLFuse keyword, a CRT list, or something else. So what can we improve? With HAProxy 3.2, we implemented the ACME protocol. It's an experimental feature for now, but we will backport everything in the next 3.2 releases if there are improvements. Any CRT keyword can be configured. So like I was saying, you can use a CRT list, a CRT store, SSLFuse, etc. You don't need to reload. You don't need external configuration. And for now, it's handling HTTP 01 challenges. So this is an example. It's quite the same thing as ACME SH configuration. Only you have an additional ACME section. And the HTTP request rule is quite the same. So you just have to use the ACME keyword with the domains you want on the same line as your certificate. We also added some command on the CLI. So you can check the status of your certificate, you can check the expiration date, the schedule dates. And there is also a command to force the renewal of your certificate. So in conclusion, it's quite simple. There is full HAProxy configuration support. However, we don't have the LP and O1 challenge, but it will be coming soon. And it's not possible to do the DNS O1 challenge for now. But Marco might have some idea about that. Also, it's not possible to save the certificate of the disk on the disk. Because you might know, but HAProxy does not access the file system once it's started. But Marco has some ideas about it.
Yeah, thanks, William. So let's first start with 3.2. So we have a data plane API also released, the 3.2, and it has full support for all the keywords that currently William mentioned, which means that you can configure ACME section and all the SSL FUs, CRT stores using the data plane API, so through the REST API. Also, HAProxy added a new ring buffer by default. It starts, it's called DP API, and when you start HAProxy, it starts. You can connect to that ring buffer on the master socket or the stat socket and listen for some events. This was implemented for inter-process communication between the HAProxy and data plane API. Now, why is this important for us? As William mentioned, HAProxy cannot store the certs that it gets from ACME on disk. So we're running data plane API together with HAProxy. Data plane will be listening for messages about ACME changes on that ring buffer. Once it gets the notification that HAProxy got a new certificate from the ACME provider, it will use get SSL CRT on the runtime, pick up the certificate, and store it on disk. This is the current workflow for HTTP challenge. Also, as William mentioned, HAProxy cannot do DNS challenge resolving, but we're going to do that in data plane API in some future versions, also in 3.2. We're going to use Go's extensive DNS client library, DNS client libraries, so we can solve DNS challenges in the data plane API. So this is what's coming soon. Also in the data plane API, all those runtime commands that William just mentioned about statuses of your ACME certificates and the forcing of renewals will be available through the data plane API. So here's a small diagram how when working together with HAProxy and data plane API, you can now implement the full HTTP challenge method of the ACME provider. HAProxy will issue a certificate request to the provider. Provider will issue a challenge, which HAProxy will solve. HAProxy will issue a CSR and download the certificate into the memory. Once the new certificate is downloaded, using the ring buffer the data plane API is listening on, it will notify about the new certificate and data plane will store it on disk. So for the DNS, I don't have a diagram here, but for the DNS challenge, it's similar, except the middle challenge part will actually go to the data plane API. Once it's solved, it will return the result to HAProxy, and this whole process will continue. So with using HAProxy together with the data plane API, you get full native support for your ACME providers. So now that we've covered how HAProxy 3.2 improves ACME for single instances, let's talk about managing this at scale. So in the 3.2 of data plane API, we've supported all the runtime commands for SSL certificates. So it means that now when you create a change to your SSL certificates endpoints, they will not reload HAProxy anymore. It will be all done through memory, through runtime. Why is this important? Because for handling ACME at scale and handling certificates at scale, that's where HAProxy Fusion Control Plane comes in. HAProxy Fusion Control Plane is already a full-scale enterprise certificate lifecycle manager, because now we have a certificates endpoint there where you can upload your certificates, renew them, revoke them, and they will instantly be sent to all the data planes in the cluster, and there will be no more reloads. So everything will be happening dynamically. And we are currently working on an ACME implementation in Fusion. So if you need to scale your ACME certificates, you you will be able to do it through Fusion. So Fusion will be handling all the communication with the ACME providers, handling the challenges, fetching the certs, and distributing it across your clusters. So stay tuned for more updates as we develop those capabilities. I think that's it.